Let's think about something for a second. When you get an email, how does it know to open in your email app and not, say, your music player? I mean, we get the data makes it to our computer, but how on earth does it find its way to the exact right program? Well, today, we're going to pull back the curtain on this amazing invisible process.
Welcome to SuperCoreseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
So yeah, this is the big question, right? You've got this single chunk of data, a packet, that just lands on your machine. What's the secret instruction that tells it where to go? How does it navigate the super busy city of all your open applications to find its one specific destination? And this right here, this is what we call the packet's dilemma. You've got one computer, but it's juggling dozens of different conversations all at the same time. It's not just one stream of data coming in. It's this flood of different information, all heading for different programs, but all on the same device. I mean, just think about what you're doing right now. You've probably got a web browser open, maybe an email client is checking for new messages in the background, you could be streaming music, you might even have a game running. Every single one of those is a separate conversation, and each one is waiting for its own specific data to arrive. And that gets us to a really crucial point. See, modern networking isn't just about getting a message from one computer to another computer. That's kind of the easy part. The real magic and the whole key to how we use our devices today is getting a message from one application to another. We need that web server to talk directly to our web browser and that mail server to talk specifically to our email client. So, how do we solve this? Well, the first part of the answer lies in the layer of the network stack called the transport layer. You can think of it as the ultimate traffic director, living right inside your computer, and its entire job is to solve the where. Officially, the transport layer's whole purpose in life is to guide those data packets to the specific application that's supposed to get them. It takes the general delivery that arrives at your computer's main address and turns it into a very specific, targeted delivery right to an application's front door. So how does it pull this off? It uses this super clever addressing system called ports. And honestly, the best way to think about it is this. If your computer's IP address is the street address for a big apartment building, then a port is the specific apartment number for each program living inside. And this port number, it's written right in the packet's header, that little bit of info at the front that carries all the addressing details. And what makes this system so slick is that we have these standardized apartment numbers, or ports, for all the common services. For instance, pretty much all standard web traffic is sent to port 80, because that's where web browsers are listening. Email clients, they're often listening on port 25. It's this universal address book for software. But, getting the data to the right door is only half the battle. Once that application opens the door, it has to actually understand the message inside. And that's where our next piece of the puzzle, the application layer, comes into play. The application layer, also known as Layer 7, is designed to solve exactly this problem. It's basically a universal translator, making sure that the data sent by a program on one computer can be perfectly understood by the program on the other end. And the way it does this is with something called protocols. A protocol is really just the specific language that an application speaks. Just like you and I need a shared language to communicate, so do applications. And just like the port number, the protocol that's being used is also specified right there in the packet's header. So, for example, when your web browser gets data delivered to port 80, it's expecting that data to be speaking the language of HTTP. That's Hypertext Transfer Protocol. And when your email client gets a delivery, it's ready to hear the language of SMTP or IMAP. Different apps, different languages. It's that simple. Okay, but if we dive a little deeper into that transport layer, things get even more interesting. It turns out there are two main ways it can handle a conversation. You can think of it as the difference between making a really formal phone call versus just shouting a message across a crowded room. So on one side you have TCP. This is your phone call. It establishes a solid connection, it says hello, it makes sure you're ready to listen, and then it sends the data guaranteeing that every single piece arrives in the right order. This is perfect for things like downloading a file, right? You need every single bit. But on the other side, you have UDP. This is the shout. It just fires the data out as fast as it possibly can, putting speed way ahead of guaranteed delivery. This is what you'd use for things like live video streaming or online gaming, where a little bit of lost data is fine, but speed is absolutely everything. All right, so let's put all these pieces together. We started with this single data packet arriving at a computer totally lost. But now we have all the tools we need to turn that raw data into a real, meaningful conversation between our apps. So here's the two-step solution in a nutshell. First, the transport layer, our traffic director, reads the port number from the packet's header and gets the data to the right application's front door. Then, the application layer provides the protocol, that common language, also in the header. So the app can open up the message and actually understand what it says. And the result? It's a totally seamless process. A generic packet of data gets transformed into a specific, understandable message for exactly the right application.
And that just leaves us with this one last thought. As you're sitting here right now, your computer is silently directing and translating hundreds, maybe even thousands of these conversations every single minute. So the next time you check your email while you're streaming some music, just take a second to appreciate that invisible orchestra of ports and protocols that are making it all happen. Just think, how many of those conversations are your apps having right now?